4 is on factoring polynomials. So it says, as you know, numbers can be factored until you have only the product of prime numbers. So if you start with 100, you can break it into maybe like 25 and 4 or 10 and 10, right? And then you can break those factors down even further. So same thing with polynomials. So we're going to continue to factor until we get what's called prime polynomials. Okay, so the first method that we're going to discuss is called pulling out a GCF, or a greatest common factor. Do you guys remember this one? So we look for something that is in common to all of the terms. So when I look at number 1, I have 10a cubed b squared plus 15a squared b and 5ab cubed. Let's talk about the numbers. 10, 15, and 5. What do they have in common? 5. So it's morning. All right, how about the a's? So a cubed, a squared, and a. How many a's do they all have? They each have at least 1, right? How many b's do they all at least have? 1. So as we pull out the 5 and the a to the first and the b to the first, we want to write what's inside parentheses. So basically we're taking all of those terms and we're dividing out by 5ab, just like we did the other day, Michael. So we're going to need a 10, in order to get the 10, we need a 2. In order to get the a cubed, we need an a squared. In order to get the b squared, we need another b. And we do this for each part. So for the 15a squared b, we're going to need a 3 and another a. And for the negative 5ab cubed, I'm going to need a negative 1 and a b squared. Do you guys see that? So if I wanted to check and I multiplied this back in, I would get 10 a to the cube, or a to the 3 b squared plus 15 a to the second b minus 5 a to the b to the 3. Right? Do we have that? Or a times b to the 3. All right, everybody understand that? All right, so let's do this on the next one. So I'm going to look for a GCF. So I have 3, 12, and 24, so I pull out a 3. I have a squared, a, and a squared, so I pull out an a. I have b to the 4th, b cubed, and b to the 5th, so what do I pull out? B to the 3. So when I multiply back in, I'm saying, what will I need in order to get 3a squared b to the 4th? So I would need another a and another b. On the next one, I need a negative 4. I don't need any more a's. I don't need any more b's. On the last one, I need an 8. I would need another a, and I need 2 more b's. Okay, so that is pulling out a GCF. So I will often say, pull the GCF to the front. All right, so the next thing that you're often going to see is the difference of 2 squares. So this is a very specific setup. So if I have something like x squared minus 81, notice how there's only 2 terms there, x squared and 81. The sign in between them is a minus. Okay, do you guys remember how to do this from Algebra 1? Yeah, do you know? What do you do?
I remember how you solve this.
Yeah?
It's just x minus 9, x plus 9.
Yeah.
X plus 9.
Yeah, definitely. So you have the x and the x that multiply to be the x squared.
And then you have the positive 9 and the negative.
So you need plus 9 and negative 9. Perfect. Good. So if you guys multiply this out, remember we kind of briefly talked about FOIL the other day. If I FOILed it out, so you can check, don't write this, but kind of watch, I get x squared. I'd have my negative 9x. I'd have my positive 9x. And then I'd have minus 81. And what happens is that negative 9 and the positive 9 cancel each other out. That's why we only have 2 terms. We don't have an x term in the middle because we had plus 9 and negative 9, which ends up canceling. Okay, so on the next one, we notice that we have 2 terms. So we want to say, is this the difference of 2 squares? Are these things something squared? So if I have 25x squared, notice how that's 5x times 5x. And if I have 16, it's 4 times 4. So this is set up as the difference of 2 squares. So it's a very simple setup. We just do the 5x and the 5x to make the 25x squared. We do the 4 and the 4 to make the 16. But we need the signs to be plus and minus so that the last terms multiply to be negative 16 and our outer and inner terms combine to go away. They cancel each other out. So do you guys see what I mean by that? I get negative 20x and positive 20x. They'll go away. So that's why I don't have an x term in the middle. How about x squared plus 4? What do you mean by no? It just doesn't work?
Yeah, it's like there's no subtraction.
Exactly, there's not a minus. So this is the sum of 2 squares, which actually does not factor. So whenever you see the sum of 2 squares, it doesn't factor. So what were some of you guys guessing? Were you thinking, oh, it's going to be x plus 2 times x plus 2? That's what a lot of people think. So if you had x plus 2 multiplied by x plus 2, and you FOILed it out like we did the other day, we would have x squared plus 2x plus another 2x plus 4, okay? And those middle terms would not cancel each other out then because we have positive 2x and positive 2x makes positive 4x. Okay, so we would still have a middle term in that case. So there is no way to factor something that is x squared plus 4. So with numbers, if I can't factor it, like 49, the only factors of 49, well, not 49, dang it, that's 41. The only factors of 41 are 1 and 41, right? Does that make sense? 41 is what we call a prime number. So this is a prime polynomial. I love how I chose 49. Oh, gosh. All right, first double in a while, right? All right, so this next one. So this doesn't look like the difference two squares. All right, but we can use that skill that we've already talked about. We can pull out a GCF first. So always look to see if you have any GCFs first. Do we? A 5 and what else? A y. So when we pull the 5y to the front, we're going to have an x squared minus 25. Now we have the difference two squares. So now we can keep that 5y out front and we can factor the x squared minus 25. And it factors into x plus 5 and x minus 5. And then we're done. All right, so there's another method that you guys learned in Algebra 1, but it's been a while, and it's called factor by grouping. Okay, so sometimes you guys have four terms. You guys see how this first example, we have x cubed minus 6x squared plus 2x plus 12. So we have four different items. Okay, so when that happens, we look to see if we can factor by grouping. Okay, so sometimes I call this splitting the middle. Okay, so we're going to split it straight down the middle. And I put the line in front of the sign with the second term, or with the third term, I mean, with the 2x. Okay, we don't always want to do it. It doesn't always work, so let's try. So in this case, I want to only look at one side. So it's like I have my fingers and I'm covering up this part. So totally cover up that part. When I have the x cubed minus 6x squared, does that have a GCF? Yeah, it has an x squared in common. So I only work with the left side. So I say, okay, well, when I pull out an x squared, I have x minus 6 left. Okay, now I'm going to cover up the left-hand side, and I'm only going to look at the 2x minus 12. Does that have a GCF? 2. Now, ideally, if I can get the same thing, this x minus 6, that's what I want to do. So am I able to have x minus 6 in parentheses and pull something out? Yeah, a 2, right? So if I have the exact same thing, that x minus 6, it works. I can pull a 2 out. Now, I always pull out a number and a sign. Okay, so what's the sign with the 2? A positive, right? Okay, now it's like we're repeating the process. We're saying, oh, well, now we have a GCF, right? So this one's x squared times this x minus 6, and this one's 2 times the x minus 6. Do you guys see what the GCF is? It's the entire x minus 6. Okay, so what I typically show everybody this each year is this is like having x squared times a number minus 2 times a number, right? They have that same number in common, that x minus 6. So we know that we would be able to pull that w, the number, out to the front. So we do the same thing here. We pull the x minus 6, the entire GCF, to the front. Do I write it twice? No, I write it one time. It's a GCF. I pulled that x minus 6 to the front. The part that was left is x squared plus 2. So I'm going to have x squared plus 2 left, like that. Do you guys understand what we just did there? So I have the entire x minus 6 in common for both of them. So I pull the entire x minus 6 to the front, and I write what's left, x squared plus 2. Okay? So on this next one, if I split the middle, go in front of that sign, I look at my x cubed minus x squared, and I say, what do they have in common? They have an x squared in common. So I pull my x squared to the front. When I do, I'm going to have x minus 1 left. Now over here, ideally, if I can get an x minus 1, that is going to be what's going to work for me. Okay, I want it to be the same so that I can do that next step where I pull it to the front. So not only do I need a 25, what do I actually need? Not just 25. I need a negative 25, right? Because if I checked and I multiplied that negative 25 back in, I'd have negative 25x plus 25, which is what I wanted. Okay, so now I have a GCF. I have this x minus 1 in common to both things. It is now a common factor. I pull that common factor to the front, right, factor it to the front. And then I'm left with the x squared and the minus 25. So I write what's left, x squared minus 25. Done? Yeah, Becca, what do you think?
Oh, it's not done because there's 5 x squared, but do you want us to put the thing you underlined in red in the front, or do you want it?
You can put it, the part that I underline in red in the front or in the back. I've been pulling it to the front because it's a GCF, so it's common. It's the common factor that we're pulling to the front. It doesn't matter when you multiply two numbers, like 5 times 7 is the same as 7 times 5. So whatever's in those two parentheses could be swapped out. You could have like x squared minus 25 first and then x minus 1 second. All right, so now this continues because now we have the difference of two squares. So we're still going to have the x minus 1 out front, but now the x squared minus 25 factors as x plus 5 times x minus 5. And again, you could write x minus 5 times x plus 5. It doesn't matter. And that's our answer. All right, so always look for GCFs first. On number 3, we actually do have a GCF in common to all of them. So we could pull out just a 3 out to the front before we even begin. So our GCF is going to be 3. And then I'd have 4x cubed plus x squared minus 8x minus 2. And now I'm going to complete the square on the part that's in parentheses. Not complete the square, what am I talking about? Factor by grouping. Complete the square is something you learn later on in Algebra 2. All right, so I split it down the middle. I pull out the x squared. In parentheses, I'm going to have 4x plus 1. I know over on the other side I want to have 4x minus 1, or 4x plus 1, I mean. So what do I pull out? A negative 2. Do you see how that works? Negative 2 times 4x becomes negative 8x. Negative 2 times 1 becomes negative 2. So just for the factor by grouping part, I have the 4x plus 1, and then I have x squared minus 2. But don't forget, you also have the 3 from before, right? Okay, think about it. Can I go any further? No, I actually can't because I have x squared minus 2, which is not the difference of two squares. Because 2 is not a perfect square. It's not like 25, 9, 16, 49. It's not one of those, okay? So we stop right there. Okay, so always look, especially on your homework, on the front page of your homework, I make the factor by grouping ones, a lot of them factor further. Okay, so look for that. So things like number 2, where we had the difference of two squares. All right, so just a quick review, factoring the difference of two squares. If you have a squared minus b squared, it factors into a plus b times a minus b. You should have probably seen that in Algebra 1. I would hope so. But ones that you probably didn't see in Algebra 1 are the sum and difference of two cubes. Okay, so occasionally you're going to see some that look like maybe like 8x cubed minus 125. Right, that would be 2x times itself 3 times, and that would be 5 times itself 3 times. See how it's cubes? Okay, so there's a formula for this, and I do expect you to know the formula. Okay, so here's how we get it. So if I have a cubed plus b cubed, I'm going to have 2 parentheses, and one is going to be a kind of small parenthesis. There's going to be 2 terms in it, and the other one's going to be a longer parenthesis with 3 terms in it. Okay. In the first parenthesis, I'm just going to drop the cube, so I'm going to have a plus b. So on the a minus b one, or a cubed minus b cubed, I'm going to have a minus b. All right, now the pattern. There's basically 3 spots here, and we're going to fill those 3 spots. In the first and the last spot, I'm going to square each item. So whatever I had here is a. I'm going to square it. A times a is a squared. Put it right there. Okay? So the first spot is going to be a squared, a times a. And the last spot is going to be the second number squared. So the b times b is b squared. And then the middle spot ends up just being these 2 numbers multiplied together. A times b. So it's the same thing for the next one. I'm going to have a squared, I'm going to have my b squared, and I'm going to do my a times b. But my signs are different. Okay? So on the a cubed plus b cubed, here's the pattern. It's the same sign as what we started with. See how I started out with a plus? So Same as what we started with. It's the same as that. The next one's going to be different, and then plus. Okay, so it's going to be a plus b, a squared minus ab, and then plus b squared. It's always same, different, plus. Okay, so this next one's going to be the same as a minus. This next one's going to be different, so it's a plus. The last one's plus. So same, different, plus. So there's a handy way of memorizing same, different, plus. It's same, opposite, always positive. It spells out soap. So same, opposite, always positive. Did you have a question, Eric?
I just wondering if this says,
So soap. All right, can we memorize that? All right, so let's try some examples with that. So the first one, so I want to recognize if it's squares or cubes. So how about this first one, squares or cubes? Squares. All right, so it's 4x times 4x, and it's 3y times 3y, so it's going to be 4x and 3y, 4x and 3y, and you're going to put a plus in between the first one and a minus in between the second one. Doesn't matter, you can have minus first and then plus. All right, so those are the ones we learned before. That's the difference of two squares. How about the next one, squares or cubes? Squares. All right, so what's being squared? This is 5xy squared times itself, right? What about the next one? What's being squared there? 12z times itself. So if I was breaking it apart into the two sets of parentheses, I'm going to have 5xy squared minus 12z, or you could do plus, it doesn't matter. I think I've been doing plus and then minus. 5xy squared minus 12z. That's your answer. Okay, next one, squares or cubes? Cubes. So we want to first recognize what is being cubed. So this is where I always do my little setup. I'm like, okay, I have x is being cubed, girls, and I have 2y is being cubed, and I have a sum in between it. Okay, so always set it up that way first so you can see what's being cubed. Okay, so I used to have my students that would write out the a's, the b's, and all that. We're not going to do the a's and b's. We're just going to know the setup.
I'm just double checking if Karen Wang ever made it to class.
Nope. Should be fine.
Okay, thank you.
All right, thanks. Hope she's okay. All right. So when I break this apart, I'm going to have a binomial and a trinomial. So I'm going to have x plus 2y for the first one. Remember, I just dropped the cubes. Do you guys see that? X plus 2y. As long as you've set it up so you can see what's being cubed, you're good. All right, and then the first spot is going to be the first number squared. So what do I get when I take this x and I square it? X squared, that goes in the first spot. So x squared. Okay, and remember there's 3 spots that I'm filling. So in the last spot, I take the second thing and I square it. What do I get when I do 2y times itself? 2y times 2y. 4y squared. Now, does that make sense to us? Because, yeah, look, x times x squared, that's giving us the x cubed. 2y times 4y squared is giving us the 8y cubed, right? But we still need that middle term because if we did FOIL it out, we would need to subtract out all of the random terms in the middle, okay? So there's, if you check it, it will work out. So what do I write in the middle? Do you guys remember? I just multiply these two things together. Yep, so x times 2y is going to be 2xy. And my signs are same, so I have the plus already. Opposite, always positive. So plus minus plus. Okay, and you can check it out. So you could try to multiply it all out. It will work. Do you guys remember what we did in 5.2 when we multiplied out polynomials? We took this x and we multiplied it into everything. We took the 2y, we multiplied it into everything. And all of those terms, almost all of them will reduce out. And you're going to end up with only x cubed plus 8y cubed. It's kind of fun. You should do it sometime. I'm not going to waste time and do it. But. All right, so the next one. So if I have y cubed minus 125, squares or cubes? Cubes. So we want to first write what is being cubed. So we have something cubed minus something cubed. So the first one is just y is being cubed. The second one is 5 is being cubed. 5 times 5 times 5 is 125. So I do my binomial and my trinomial. The binomial, we have y minus 5. We just drop the cubes. For the trinomial, I square the first item, y squared. I square the last item, 25. I multiply the two together. So 5 times y. I ignore the signs, right? I just take 5 times y. And then I do the signs at the very end. So minus, do you guys remember? Same, opposite, always positive. Plus, plus. Is that making sense? You guys want to try number 5? All right, so you should have recognized that it was 3p was being cubed, and then it was 5q was being cubed. So when you do your binomial and trinomial, you should get 3p minus 5q. You should square the first one and get 9p squared. Did you guys all have that? The last one should be 25q squared. But what about in the middle? Yeah, it would be 15pq, and then your signs are same, opposite, always positive, so it's going to be plus and plus in there.
So when you multiply the terms in the binomial,
You don't worry about the sign, just the items. Yeah, 3p and 5q. All right, so number 6, what do we notice about number 6? It doesn't look like it squares or cubes, does it? Maybe squares, but then we have that 32. 32 is not a perfect square. What do we do? Yeah, GCF. Did you guys see it? It's a GCF one. So before we even begin, we say, oh, wait, there's a GCF. I'm going to pull out the 4 and the t squared. We always pull out GCFs first if possible. So I'm going to have a 4t squared out front, and I'm going to be left with t cubed minus 8. T cubed is t times itself 3 times, and 8 is 2 times itself 3 times. So I have my 2 cubed and minus a 2, or a t cubed minus 2 cubed. So when I factor this, I'm going to have my 4t squared out front, I'm going to have a binomial, and then I'm going to have a trinomial. So I'm going to have t minus 2, I'm going to have t squared and 4, multiply the two together, 2t, same, opposite, always positive. So that's my final answer. So always look for those GCFs first. All right, so the last method that we're going to talk about is the one that most people, when they talk about factoring, like being difficult in Algebra 1, it's because of this. And I, maybe I'm conceited, but I feel like many Algebra 1 teachers are not very good at teaching this. Okay, so if you were confused on the ones that had 3 terms, okay, this is your year. You're going to figure it out. Okay, so these are a little bit tricky. So the thing that I think a lot of Algebra 1 teachers make the mistake of is they say, find the number that multiplies to be this and adds to be this, right? That only works on some of these. It doesn't work on all of them, okay? So it only works on the ones that have like an x squared out front, but not the ones that have like 2x squared or 3x squared. Okay, so we're always going to go back to our FOIL. We're always going to be thinking about foiling something out, okay? So on this first one, if I have 3y squared minus 2y minus 5, I'm going to think about how we did this with FOIL, okay? So in order to get the 3y squared out front, I have to have a 3y and a y to multiply to be 3y squared. Do we understand that? So I put my 3y and my y in their positions. Now if I'm foiling this out, my first terms multiply to be the first thing. The spots right here on the ends, those multiply to be the number, the negative 5, okay? So these spots on the end multiply to be negative 5. So I know that I need 5 and 1, and they're not going to be the same sign, they're going to be opposite signs, okay? So I'm going to put 5 and 1 in here. So let's say I put the 5 here and the 1 here. So I've taken care of my first and my last from the FOIL, and those look okay. I have my 3y squared, I have my 5, I know that they're going to be opposite signs, so I'll make 1 plus and 1 minus. But what else happens in FOIL? So first and last, but what's on the inside? Outer and inner, right? Do you guys understand what I'm saying? So look at my outer swoop and my inner swoop. Are those ever going to combine to be the negative 2y? No. I have 15y and I have 1y. That will not work. Okay, so when you get that something doesn't work, all we do is we draw a line through it. Because we want to see which ones we've tried. But now, do you guys see where the 5 and the 1 are going to go? The 5 has to go here and the 1 has to go here. And I know that I have 3y and 5y. Can 3y and 5y combine with opposite signs to be -2? Yes, I would need a negative with the 5 and a positive with the 3. So that way I have -5y and +3y. They add together to be -2y. That is how you factor that, okay? So done. All right, so this next one, I have 6x squared minus x minus 2. So I want to set up my parentheses, and I know 6 could be two different things. I could have my 6 and my 1, or I could have my 3 and my 2. So that's where factoring starts to get a little bit tricky. But my 2 is definitely 2 and 1. Okay, I usually, when I'm factoring, pick the numbers that are closer together. So I don't usually do 6 and 1. I usually would try the 3 and 2 first. Okay, so let's say I try 3x and 2x. If you guys are smarter than the problem, these will be a breeze for you. Factoring will be really, really simple. In your original problem, did I have a GCF that I could pull out? I did not. I had 6, -1, and 2, right? Do you guys see that? There's no GCF. So when I have 2x here, and I'm picking between the 2 and the 1, I'm like, oh, I could put the 2 here and the 1 here, or the 2 here and the 1 here. Since there was no GCF originally, I cannot put the 2 there. Do you guys understand why that's can't go there? Yeah, it would now have another GCF, right? I have a 2x and a 2 in the same parenthesis. I could pull a 2 out. The 2 can't go there. So what's the only number that can possibly go there? 1. So I put the 1 there and the 2 there, and then I start to look at my outer and inner. So when I look at my outer and inner swoops, I know that they need to combine to be the x term, -1x. Can they combine to be -1x? Sure, if I do a negative with the 2 and a positive with the 1. Done. That's it. So we have 6x squared on the first ones, we have -2 on the last ones, and the outer and inner do combine to be the -1x. All right, how about the next one? What do we notice before we even begin? There's a GCF. You have to pull those GCFs out because it makes your problem so much easier. So we pull out the 4. We have 2z squared minus 9z minus 5. So the 4 just stays out front. We totally ignore it. And we're like, okay, I know I need 2z and z to make that 2z squared. Okay, so now you should be starting to get pretty good at these. Think about it. We want these last numbers to multiply to be -5. But we want our outer and inner swoops to combine to be -9. Think about where you're going to put the 5. Do I want the 5 here and the 1 here? That would be 5 and 2. Do I want that? So think about it. Do I want a 5 here and a 1 here? No, I get 5 and 2. Are they going to combine to be -9? No. Where do I want the 5 and the 1? 1 first, 5 second. Do you guys see it? Because I'm going to get 10 and 1. Which one has the negative? Which one has the positive? The 1 has the positive, the 5 has the negative. Does that make sense? Outer and inner combine to be that -9, we're good. Let me scooch that 4 closer so the 4 is there. So our final factor form is 4 times 2z plus 1 times z minus 5. All right, next one. Do I have a GCF? No, because I have that 1x, right? So my possibilities for 12, I have lots of them. I have 1 and 12, I have 2 and 6, I have 3 and 4. So I would probably pick the 3 and the 4. All right, and then 6, I have lots of things. I have 1 and 6, I have 2 and 3. Okay, so if I start out with 3 and 4, there's only 2 possibilities that can go with the 3 because of the GCF thing. I can't put a 3 there. I can't put a 6 there. So what do you guys want to try? Let's try the 2. Exactly. So do you guys understand that I cannot put a 3 here and I can't put the 6 there because then there would be a GCF that I could pull out. So I'm going to go ahead and try the 2. So when I try the 2, I'm going to need the 3 to go with it to make that 6. And they're going to need to be opposite signs. So when I look at my outer and my inner, I have 9x and I have 8x. Can 9x and 8x combine with opposite signs to be positive 1x? Yes. So I need a positive with the 3 and a negative with the 2. Are you guys like, oh my gosh, factoring is not as hard as I thought it was? Wow. Usually the second time around. Once you guys have seen it in Algebra 1 and then Algebra 2 again, it's like, oh, okay, I got it now. All right, next one, 10x squared minus 61x plus 6. Are you seeing it before you even start the problem now? No? Not so much? All right, so for this one I have 2 and 5, but I also have 10 and 1. For this one I have 2 and 3, and I have 6 and 1. Okay, that is a big number in the middle, the 61. It's kind of hard to get. So if you try those numbers that are close together first, like 5x and 2x, and then let's say I tried the 2 and the 3, I know the 3 would have to go here and the 2 would have to go here if it was going to work, because the 2 can't go with the 2x. And likewise, the 6 can't go with it. It's not going to work. I get 15 and 4. That's nowhere close to 61. Do we see that? So even if we tried and we're like, oh, what if I tried the 6 and the 1? Well, the 6 and the 1, I can't put the 6 with the 2 because of the GCF, so I'd have to put a 1 here and then a 6. It still doesn't work because I get 12 and 5. So every combination with that 5 and the 2 does not work. So what do we try now? Yeah, we try that 10 and 1. So we do 10x and 1x. We want to get 61 on the inside. So we want the 6 on the outside and the 1 on the inside, right? So that way we're getting 60x and 1x. And we make them both negatives because we want them to multiply to be that positive 6, and then the outer and inner terms are going to combine to be the negative 61. Make sense? You guys get it? So sometimes when you see you have a big number on the inside, it's like, oh, well, maybe I'll try those extreme values, those bigger values. Maybe it will work. All right, this one has a GCF, so pull out the GCF. We have a 2. We have a no x's. Do we have a y? Nope, just a 2, right? So we're going to get 5x squared plus 17xy minus 12y squared. And don't let it freak you out that you have x squared and you have y squareds. Because in our parentheses, we're going to have 5x and x, but our numbers on the end aren't just going to be numbers, they're going to have y's. Okay? So how about 12? What do we want to try with 12? Yeah, let's try 3 and 4 first. So we have 3y and 4y. I know they need to be opposite signs. Did that work the way I just put it in there? That was lucky, wasn't it? It does work. 20 and 3. Do you guys see it? 20xy, 3xy. I want them to combine to be 17xy. So I put a plus with the 4 and a minus with the 3. Okay, so one step at a time. Sometimes it takes quite a few attempts, so don't be discouraged when you have to try several things, okay? All right, so these next ones say factor the polynomials using any method. So any method. So notice we have a GCF first, so we pull the GCF to the front. We have a 5 and we have an m. So we pull the 5m to the front. We have a p squared minus 9 left. So we say, does it go further? Just like with numbers, does it factor further? Yeah, when I see p squared minus 9, it's the difference of two squares. So I have p plus 3, and I have p minus 3. And then we're done. How about the next one? What do we think? Yeah, they're actually things that are cubed, right? Something is cubed plus something is cubed. So the numbers that are being cubed, we have x, I don't know why I was writing 2 there, xy is being cubed, and we have 2 is being cubed. Do you guys all recognize that?
Should you put x and y together, or should you do x and y separately?
Well, xy in parentheses cubed, you would get the 3 goes into both of them. So we're good. All right, and then we do our binomial and trinomial. So it's a little tricky because it's xy is that first term. So what do I get? So I'm going to drop the cubes and I get xy plus 2. What do I get when I do xy times itself? xy times xy. X squared, y squared, or xy in parentheses squared, right? Either way. All right, what do I get when I do 2 times 2? 4. How about the middle? Xy times 2? 2xy. Same, opposite, always positive. So, done. All right, and then some of them are kind of super challenging. So the part C, so I have 64x to the 6th minus y to the 6th. So when we say is that the squares are cubes, it's actually both. 64 is 4 times 4 times 4, it's a cube. But 64 is also a square, 8 times 8, right? So I gave you a little hint. It says when you have the 6th power, use the difference of squares first. So this one's a really tricky one. Are we ready for it? Maybe. So we're going to break it apart using the difference of two squares. So I'm going to say, okay, well, I'd have 8x cubed times 8x cubed makes 64x to the 6th. And I have y cubed times y cubed makes y to the 6th. So plus and minus. Now what do you notice? Cubes, right? This one is 2x is being cubed, and this is y is being cubed. And this one is 2x is being cubed minus y is being cubed. So how many sets of parentheses am I going to have? 4. So I'm going to have my binomial and a trinomial, and then I'm going to have another binomial and a trinomial. So the first one is just going to be 2x plus y. Square the first thing, so 2x times 2x is 4x squared. Square the last thing, I get y squared. Multiply the 2x and y together, I get 2xy. My signs are same, so I already have the same written. I have the plus. Opposite, always positive. And then I do the same thing for the 8x cubed minus y cubed. So it breaks into 2x minus y. 2x times 2x is 4x squared. Y times y is y squared. In the middle, I have 2x times y. Same, opposite, always positive. Hard, isn't it? Now, never try to factor the trinomial. When you do the difference of cubes or sum of cubes, this part will actually not factor. Okay, so you're done there. You don't have to continue that. All right, and then the last thing we have is sometimes maybe we have something called a rational function. We have like a numerator that has a polynomial and the denominator that has a polynomial. All right, you could do this with long division, but we don't. Like if you see something that's a squared over a squared, we want to look to see if we can factor things. And we'll do more of this in chapter 9. So it says sometimes factors cancel, like with numbers. So for instance, if you had 45 over 25, you could say, oh, it's 5 times 9, and it's 5 times 5, so I can reduce out the numbers. 5 and 5 cancel, and I get 9/5, right? So we can do the same thing with polynomials. So if I factor the numerator and I factor the denominator, and then I see that I have something in common, I can reduce it out. So if I have a squared minus a minus 6, I would factor as a times a. The 6, I'm going to have a 3 and a 2. And I want the outer and inner terms to combine to be negative a. So think about where that negative goes. Negative 3, positive 2, right? Okay, and on the bottom I have a and I have a. I want to multiply it to be 10, and I want my outer and inner to combine to be 7. So let's do 5 and 2, and they're both plus. So what do we have in common on the top and the bottom? A plus 2, right? So our final answer is a minus 3 all over a plus 5. You cannot, yeah. So if you had numbers, let's say we had 7. 7 minus 3 over 7 plus 5 is going to be 4 over 12. It's not the same as negative 3 over 5, right? So we can't reduce out the a's. And same thing at the very beginning. A lot of people try to like cancel here and here. We don't do that, okay, because we have the sum or difference. All right, so let me pass out your homework.